Welcome to the No Shit Podcast. I'm Matt Frazier, your host. Today's Friday, December 1st, 2017. My guest tonight and often my co-host, Eric Smith. How you doing tonight, Eric?
Good. How are you, Matt?
Not too bad. So some interesting things have been going on with the podcast here recently, and I'd like to share it with the listeners. We got picked up by a promotional company that's promoting us now and doing all of our web development and stuff like that. It's called the X Factory. So if you get a chance, I would highly suggest you check it out. They do a really good job of promoting new artists and things like that. It's a really good organization. You can donate to them, and they also have some products it looks like you can buy as well.
All kinds of stuff.
Yeah. It's the web
all
address.
Original.
Yeah. Oh, yeah. And they're all right. These are all original artists, up and coming artists that may not necessarily have any exposure yet, but are really talented. So the website is www.thexfactory.com. Again, www.the letter X and then factory.com. And would like to put a special thanks out there to Tangent, who's been working with us from over there. He's been doing a great job, diligently working on No Shit's website actually right now because woohoo, we're going mainstream. Yep, thank you, Tangent. So the website is there, the frame's there, the website's being built right now. For the podcast, it's going to be called noshitcast.com. So it's www.knowshitcast.com. So that's us. We hope to have that up and running by March 1st of next year. But if you get a chance, go to the X Factory's website, check it out. Who's this? There's a artist up here. You can listen to a snippet. Cat Hall. Ephemeral Aka. So SoundCloud files, things like that.
Yes.
Really good stuff. And I think you've got some stuff. I
don't know.
Oh no, yeah, I don't know that you ever published with Tangent, did you?
Well, it did, but I don't know. If it's been. I don't know.
See if it's even there or not, right?
Yeah, I don't know. It probably is. It probably is.
So, a little housekeeping there, exciting stuff. The podcast is moving in, I guess, a positive direction. Tangent cracking the whip and trying to make us look like a professional organization, if that's even possible.
And I often don't know what's going on. In a lot of instances, speaking of what my music may be being on there. Maybe
well, you can see how well I vet my guests, ladies and gentlemen, right? My guest tonight often doesn't know what's going on.
Yes.
So, you kind of had some ideas about some stuff you wanted to talk about, right?
Consciousness.
So nothing too heavy, right? We're gonna.
No, actually, for the subject matter, not as heavy as it could be, man.
So
it could be a lot heavier.
What do you want to talk about tonight?
I want to talk about consciousness, in essence, just what it is that makes you aware, self-aware. And I want to preface this by saying that I am not an authority on any of these things. These things that I'm talking about, I encourage people to go and check out for themselves and read up on it. But I do know a bit about it, and in particular, I'm going to talk about a theory of consciousness called Orch. It's a theory of quantum consciousness. Classically speaking, what people think happens that gives rise to consciousness is that there's so many complex computations going on in the brain that all of these computations add up to self-awareness. It's called emergence. It's considered to be an emergent property, that if a system gets complex enough, out of that will arise intelligence.
Well, now, let me pull you back a little bit, because you said that you're not an expert, right?
No.
So this is something that interests you that you've done your own kind of research on, or
Yeah, it started off being interested in quantum physics, and that's kind of what pulled me into it. But the discipline, or the theory, I should say, because it's really not a discipline, but the theory touches upon quantum physics, biology, mysticism, and reincarnation, and implies a lot of different things. Uh, it's a pretty deep theory. It's got a lot of implications and that sort of thing.
and it's a it's a quantum physics theory.
Yeah, it's based on quantum theory. The OR stands for Orchestrated Reduction of Quantum Entangled Information in Micro-tubulars in the Brain. And I know that's a lot. That's why they call it OR, but that can all sort of be decoded. But, the important thing I think to start with is that classically speaking, what we assume happens, the going theory, the strong theory, the winning theory, is that self-awareness arises out of complexity. So, this theory goes against that.
So I'm looking. I'm going to just read this because this is from the Wikipedia, the wiki page for the topic. Okay.
Okay.
Orchestrated objective reduction, or OR, is a hypothesis that consciousness in the brain originates from processes inside neurons rather than from connections between neurons, or what would be the conventional view. The mechanism is held to be a quantum physics process called objective reduction that is orchestrated by molecular structures called microtubules. Objective reduction is proposed to be influenced by non-computable factors embedded in space-time geometry, which thus may account for the hard problem of consciousness. The hypothesis was put forward in the early 1990s by theoretical physicist Roger Penrose and anesthesiologist and psychologist Stuart Hamerhoff. Now, what in the hell does that mean?
Okay, well, there might be a situation where we'll have to back up and talk about other things, but just to go through that sentence by sentence, it's a hypothesis that consciousness in the brain originates from processes inside neurons rather than from the connections between neurons. So the conventional view is that when you are stimulated, so you see an image or you hear a sound or you taste something or feel something, there is a bunch of neuronodes that's activated in your brain that decodes what that thing is. The way these neuronodes are activated is that between the neuronodes are synaptic circuits, and the biochemical energy gets propagated through these neuronodes, activating them, and it gets complex enough to decode whatever the stimuli is. You recognize it, once enough neurons have been activated, which is why I think some people have said that memories are stored in the neurons in that way, because you have to activate enough to piece together whatever it is that you're being stimulated with, the sight, the sound, or the combination of those things. And once enough of those neurons are activated, you get the image. You recognize the image or the sound. What they're saying in this theory is that it originates from the process inside the neurons, because inside the neurons are cells that these neurons are made out of. They're made out of cells just like anything else in your body. And these cells have a skeleton. It's called a cytoskeleton. And this cytoskeleton has these things called microtubulars in them. And this theory stipulates that these microtubulars resonate with quantum fluctuations. So it's basically a part of the body that's connected to the quantum world. In fact, that has been proven that the microtubulars in cytoskeletons of cells and neurons do vibrate in quantum fluctuation.
What does that? I mean, okay, so the significance of that is
that the human body is connected to the quantum world. And so that's what they're saying. And there's a process on how this actually happens, and I can explain that. But for now, they're saying that this process happens inside the neurons and isn't a matter of being decoded. It's a matter of a wave function, a quantum wave function collapsing in an orchestrated manner, which I'll get to that in a minute. But it's a different process. Then it says after that, the mechanism is held to be a quantum physics process called objective reduction that is orchestrated by molecular structures called micro-tubules. So that's kind of what I was just saying, that it's a mechanism. And the reason why it's called objective reduction in that sentence is because quantum wave functions normally collapse because of dissidence. Hey, we just heard a song from a band or an album called Dissonance, right? Cat. And so dissidence is basically the subatomic particles in quantum physics that appear and decay, and things like the second law of thermodynamics, entropy always increasing, and this kind of bubbling ferment soup of subatomic particles that's constantly going on, right? So when a wave function is there, it collapses generally because of these things.
And the wave function is what?
So the wave function is a way of looking at superpositioning. In quantum physics, you know how you can have a state take two different states at the same time? You know, like when you're talking about quantum computing, instead of having binary programming being zeros and one, you can have 0, 1, and in between with quantum computing. You have qubits.
Yep.
Okay. So that's basic
fuzzy logic.
Yeah, that's basically superpositioning, right? So then normally the superpositioning collapses into a specific position. So you've heard people talk about the uncertainty principle and about the active observation on the quantum level will change.
Yep.
Right. And so you're
measuring something always affects it.
Right. And every time you measure something, what you're doing is you're collapsing the wave function of that quantum state. You're figuring out at that moment in time that you did the measurement where that quantum fluctuation actually was. Like, so for instance, an electron that's around an atom, like your average hydrogen atom that has a nucleus with one electron going around it, the electron is said to have a spin. I think it's either spin 1, 2, which is like up, down, or in the middle. And these sections are just the probable location that you're going to find this electron anytime you take a look for it. And then when you do take a look for it, you'll know where it was when you took a look for it, but because you took a look at it, you've actually changed its trajectory and you've potentially changed its energy. So now it's going, when you get the information back where you recorded it at, it's going to be someplace else, right? It's going to be back in that wave function that's described. And wave mechanics, mathematics, are used to calculate the probable position at any moment in time that you're going to find this electron in a spin. So, and of course, when you measure it, you know exactly where it's at, but then you don't, because once you get that information back, it's already someplace else. Now, I can go into more detail. That's the uncertainty principle, if you want me to, or I can go on with the sentence that we were in on this. I don't know where to go. Like, should I go deeper into why that's relevant, or should I go ahead and just finish out this sentence?
Well, yeah, let's finish this out,
Okay.
and then we'll circle back to that when it becomes
Okay.
relevant again.
So that's the wave function, and just suffice it to say that quantum wave functions normally collapse because of dissidence, just the environment around it collapsing it, or when you measure it. But this is objective reduction. So when the quantum wave function collapses, that's called a reduction. It's called a reduction because it's went from all possible positions into one reduced position, right? So objective reduction means that you've been able to influence or choose how that wave function collapses. Isn't that neat? You guys, if you should have seen Matt's face, he looked like, hey, that sounds interesting. And that's part of this theory, is that you can objectively allow this wave function to collapse. And the objective collapsing of this constant wave function is your constant stream of thought.
So basically what you're saying then is that your consciousness never feels broken. It never feels like you're always self-aware because of this continuous collapse, this objective collapse of this wave function.
Except in one particular instance. Can you guess what that might be? That instance might be?
When you get hit by a bus.
Well, that's close, because like you would maybe die.
Yeah, right.
But even that's not the instance. Apparently the instance is when anesthesiologists put you under. If you've ever been put under for an operation, you'll know that, you know, you may have been smashed on alcohol or some drug, or been tired because you've been up for a week, or you worked your butt off, or whatever the issue is, and you've fallen into a deep slumber. You've woken up, but you've had a basic idea of how long you've been asleep, right? But when you've been knocked out for a surgical procedure, it's like switch on, switch off.
Well, the same is true for anybody that's ever been like choked out, where you've had the blood flow to your brain limited. Oftentimes, when someone wakes up from that, they have no concept of how much time has passed. They either feel like no time has passed at all, like they blinked, or they'll have a tendency to feel like it's been hours and it's really only been moments.
And this is because if you're starving the neurons of blood, they're not going to be able to function. And it's similar to how people are put out with anesthesia. And so you're completely off at that point. You're separated from everything, which is something that even death doesn't do. There's been studies recently that talk about genes being turned on or off after death, and brain activity going on for up to like 10 minutes or so after death. I mean, death is more of a transition that's starting to look like in science than it is a point that you reach, or a boundary of which point when you go, you're definitely dead, right? Like now they're starting to like, well, you know, mostly dead is good dead enough, you know.
It's the Princess Bride all over again, right? He's not dead, he's just mostly dead.
Right, exactly.
Liar!
So these are orchestrated, continuing with this sentence in Wikipedia, that is orchestrated by molecular structures called microtubulars. So as I was saying before, microtubulars are the parts of the cytoskeleton, and the cytoskeleton is the thing which gives a cell its shape and allows it to move and allows it to divide and stuff like that, right? And your body is completely made of cells. You got brain cells and liver cells and skin cells. And so they're saying that the cytoskeleton inside of cells, particularly the cells inside of the neurons in your brain, use these microtubulars to orchestrate this wave function collapse. And again, I don't know if I should get into how this happens, or if I should go ahead and go on with the sentence. Should I go on with the sentence? Okay. And we can get back to that if you want.
Yeah, definitely.
Objective reduction is proposed to be influenced by non-computable factors embedded in space-time geometry, which thus may account for the hard problem of consciousness. Okay, so it says it's influenced by non-computable factors embedded in space-time geometry. So there is, now this is a part that I don't understand as much as I would like to understand, but essentially this is a philosophical problem that they're talking about, and you just navigated away from the sentence for me, so you might have to go back.
That's okay.
Oh, sorry. Sorry, I lost my train of thought.
Well, I'm looking up the hard problem of consciousness.
Right. Well, let me give you a really
sense for what
basic explanation of what it is. It's a philosophical situation, right? And basically, it's a philosophical situation that says that you can't pick for something that's happening right at the present or in the future, right? Because you know how we were talking about how this theory talks about an objective reduction. like you're getting to pick how this thing reduces, right? Or
right.
how this quantum wave function reduces, right? So this philosophical issue is saying that you can't do that. It's like you're right on the edge of your consciousness, and you're saying that you're somehow orchestrating what's happening in the moment. So take a look at what you were going to.
It says the hard problem of consciousness is the problem of explaining how and why we have qualia or phenomenal experiences, how sensations acquire characteristics such as colors and tastes. Contrast this with the easy problem of explaining the ability to discriminate, integrate information, report mental states, focus attention, etc. Easy problems are easy because all that is required is for their solution is to specify a mechanism that can perform the function. So what they're talking about here is phenomenal experiences, right? So that's
connections.
It's like a step above just interacting in the physical world.
Right, and they're saying that those connections are made because of what's happening in the stimuli around you, right?
Exactly.
And that's how they're formed, and you're not objectively picking those things in some fashion, right? Now, the theory of OR says, in fact, that you are. It's saying that, and this is a very complicated part for me, at least. So we're in the microtubulars in the brain, right? They resonate with quantum fluctuations, and when they do, the resonations inside of them take on a superposition and a helix faction. So in this superposition that they're in, they are affected by space-time geometry. So here's a whole different aspect to this theory. Space-time geometry, we haven't even talked about. Space-time geometry is the relativistic view that space and time are connected. The evidence of this is seen in a couple of ways. Like, for instance, when the clocks move slower on Earth than they do in satellites orbiting Earth, the cesium atoms actually vibrate at different rates. And the reason for that is because on Earth we're closer to the gravity well that Earth creates, and the closer you are to a intense source of gravity like a planet or even like a sun or larger, the slower time goes. In fact, Professor Susskind is the person who won the black hole wars and won the information paradox between Stephen Hawking and I think it was Kip Thorne, by stating that all information was stored in a two-dimensional fashion on the event horizon of a black hole instead of being sucked in and taken out of the universe or having Hawking radiation bleeding it back out, right?
Right, yep.
So this is some of the stuff that's involved in space-time geometry, right? And so now we're talking about space-time geometry on the Planck level, the very, very small, like we were just referencing very large gravitational things and stuff, right? But we're talking about and also another one is the curvature of light, which was proved in like 1930 or something, 1919 or something like that.
That was all part of the solar eclipse, and
yes.
They were looking at the position of stars,
yes.
And that also was the proof for Einstein's theory of relativity.
That's what I'm saying. We're talking about taking relativistic views of space-time geometry on a Planck level, which is like getting into the quantum level.
Explain the Planck level.
The Planck level is basically the smallest unit of measurement that we can measure with. When you're measuring on the Planck level, you're measuring down into the subatomic level, smaller than a cell, smaller than a molecule, smaller than an atom. You're talking about the things that the constituent components of the universe that everything is made up out of.
So put this together, right? So there's a theory then that consciousness exists in the vibration of these microtubules,
and that these microtubulars are affected by space-time vibrations on a small level, so that what happens is, and this is kind of Penrose's part to it, is that the superpositions make like a bubble in space-time, so that all of the different possibilities are within this sphere, and that when it gets so big, it collapses objectively because of space-time only allowing it to get so big. And that when that happens, because it's propagated through your neuronodes, it's your consciousness. So the decision you're making is in the moment. The thought is in the moment, right? And so you're objectively thinking or doing, or this is the thing, right? This is what's separating you from the animals. You're in the moment. You're able to understand and produce ephemeral qualities in works of art and stuff. And that's what they're saying, is that it's this objective collapsing, and the idea that space-time geometry on a Planck level will only allow this to happen so much. And there's other components involved in it too. But before we get too far into that, back to this crazy sentence. So that's the part being influenced by non-computable factors. So the non-computable factors are the factors that are rising from space-time, the geometry of space-time. Because computable factors would be like in the classical view, where the network gets so large that it becomes self-aware, but you could compute those factors, or you could compute the outside environmental factors to some extent, right?
Right.
But these are non-computable factors because they are in superposition, right? So they're non-computable. Non-computable factors embedded in space-time geometry, which thus may account for the hard problem of consciousness, which I don't know how that actually applies to this as much as I would like to, but, feel free to go through and read it, and I'm sure they will explain what the issue is. I do know it's a bit specialized for this particular theory. And then the last bit of this is the hypothesis was put forward in the early 1990s by theoretical physicist Roger Penrose and anesthesiologist and psychologist Stuart Hamerhoff. So Stuart Hamerhoff was the anesthesiologist, and he was the one who was noting this on-off switch when he was able to deaden the neurons and that sort of thing. And by deadening these neurons with these particular drugs and stuff, he was able to come upon this theory. He also, I believe, did studies in cancer studies before becoming an anesthesiologist, maybe after, but he studied rapid cell division, and I know that had a lot to do with the cytoskeletal structure of cells, because I believe it's the microtubules that are extended from the cell when they start to divide. It's like the first thing that's extended and the last thing to retract. And then Roger Penrose has been pretty famous. He's a British physicist, and he's been pretty famous, much more so than Stuart Hamerhoff. And I don't know as much that he's done with quantum physics, but I'm sure he has done enough to back this theory. And he's like he's got a pretty prestigious position.
So how does this all stitch together then, right? So you're saying that there's this bubble created in space-time, and that the theory is that individuals' consciousness resides in that space-time bubble?
That a combination of an individual's consciousness in the moment and what is in the space-time geometry. Presumably, what's in the space-time geometry is the entangled part of this theory. I don't know if that made sense, but so part of this theory deals with entangled particles. So first, maybe a word.
Quantum entanglement.
Yes.
So spooky action at a distance.
That's what Einstein called it.
Okay. Same thing.
Yep.
Okay.
And yep, same thing. So the basic idea is quantum entanglement is something that we have observed, that we see it occurring, and we can create it as well. We've created quantum entangled molecules or atoms and separated them and changed. And here's what quantum entanglement is. What it means is, if you take two atoms, and let's say for example that they're both hydrogen atoms, so you've got your nucleus and your one electron, right? And you bring them together and you entangle them. Then you separate those atoms. And if you do something to one of those atoms, the other one will change instantaneously. So if the electron gains a different higher state, it quantum tunnels to a higher or lower energy state, same thing will happen with the other one. And that doesn't sound like a big deal to a large extent, but the big deal about it is that it's instantaneous. Because as far as we know, and as far as we've been able to test, there's a speed limit to the universe that was set by Einstein in the theory of relativity, which is the speed of light. And nothing can go faster than the speed of light. No energy, no radio wave, nothing. And as an example of how big the universe is, it takes 8 light minutes for the light from the sun to reach the planet Earth, which is a little over 94 billion miles, million miles, or billion, billion miles, and it's an astronomical unit. And the nearest star to us is Proxima Centauri, which is about 4.3 light years away. So that's light traveling at 186,000 miles per second for like 4 years just to get to the nearest star that you can see in the sky. So that's a long delay. If somebody was on that nearest star and you had to communicate with them, the only way you could do so would be with some sort of energy device like a light or a radio wave or something of that nature.
Traditionally, right?
Right. Well, I mean, I don't know. I don't think there's any other way you can, right? Yeah, I mean, you mean traditionally as opposed to this, right?
As opposed to something we don't know yet.
Right. Yeah. I mean, right now it's the best we can do, and probably will be the best we can do if the laws of physics hold out.
Exactly.
So it would take 4 years for a message to get from Earth to that star, a little over 4 years, and then another 4 years for that message to come back. So, 8 or 9 years for a message to go and an answer to come back, right? But if you had, as an example, as like a sci-fi example, if you had 2 walkie-talkies that were made out of atoms that were all entangled with each other, you wouldn't even necessarily need an energy device to power them. You could just speak into the membrane of one, and it would vibrate, and the other atoms would vibrate light years away instantaneously, and you'd have instantaneous communication.
So, almost calling it a walkie-talkie is a misnomer, because there would be no it's not, because a walkie-talkie has an antenna.
Yeah.
It transmits radio energy, right? You're saying that's not what's happening here. There's some sort of
spooky movement at a distance going on that no one, including Einstein, knows how that happens or why it happens.
Yeah, they got the magic string, right, that goes from the 2 cans. So that's more, but it's instantaneous regardless of how far apart they are, right?
Right. So this theory is saying that this information, this constant orchestrated collapsing of the wave function that is your stream of consciousness, right?
Right.
That this constantly happening is creating inside of your neurons entanglement, so that the atoms that are inside of your neurons become entangled, right? So that means that when you die, they will still be entangled. You won't be able to destroy your atoms unless you split them. And if you do, you're just going to release the energy inside of them, and the quantum parts of those atoms, the bosons and stuff like that, could possibly be entangled too. We don't really know. So atoms themselves, right? Atoms inside the nucleus are made of neutrons and protons, right? And there's only 4 forces in the universe. There's the strong force, the weak force, electromagnetism, and gravity, right? That's it. Everything else derives from those 4 forces. We understand some of them. The strong force is the force that binds the nucleus of atoms together. It's the thing that holds the neutrons and the protons together, right? And the force-carrying particle for this is called the gluon. Okay, the gluon in quantum chronodynamics, which is the theory, quantum chronodynamics, is the force-carrying particle that is the force-carrying particle of the strong force. So in electromagnetic, or in quantum electromagnetic theory, the photon is the force-carrying particle for that theory, right? So this is kind of analogous to that. And the gluons come in 6 flavors, which are, these are particles, subatomic particles.
Blue diamonds.
They come in, they're colors. Yeah. Yeah, that's what they call it. They call it color theory. If we don't want to call it, quantum color chronodynamics. That's what technically it's quantum chronodynamics, right? But it's really color theory, and that's why it's because these things come in these different ways. These particles can decay into different states like this. Neutrinos are like this too, right? So anyways, the gluons are just some of the subatomic particles that are inside of an atom, right? So if entanglement has anything to do with them, and you even destroy the atom, there's still a possibility that entanglement might still exist. I don't know, right? Like there, you're just really talking about the edge of science and speculation.
Yeah, because it kind of sounds to me that what you're saying is that there might be a scientific platform, or I don't know what you would call this, for the existence of consciousness after death.
Yes, this is how it borders on mysticism, which is something I said at the beginning.
Right,
touched on a lot of different things. And then, once you get into mysticism...
Because if your consciousness is stored through quantum entanglement, then once it's entangled, it's entangled. I mean, that's it. It's there forever, right?
Not only is it there forever, but it's outside of the space-time geometry. And it's comprised of components that are subatomic, so smaller than a Planck length. So what were we just talking about that affected your consciousness? That was it was the space-time continuum on a subatomic level, right? So perhaps that decision, part of that decision of the moment, comes from the universe at large.
Okay, now let me see if I have this though, because and you'd mentioned this earlier, right? That time is relative to things like gravity and speed, right? How fast you're moving, right? So if that's the case, then you're saying that consciousness is also affected. The expanse of your consciousness theoretically is also directly affected by those same things, right?
Possibly, probably. We don't know for sure, but one would say that that's a distinct possibility, because again, there's only 4 forces in the universe and gravity is one of them, right? So it does stand to reason that there might be some sort of influence, but these are things that people are just now, theoretical physicists are trying to study, and people at the Large Hadron Collider are trying to figure out things like this, like in fact, does the quantum world respond to gravity? Because on the surface, you would think not, right? Because gravity is generally a macro sort of a situation. But you don't know, right? And it's possible that, maybe I'm getting ahead of myself on this. So going back to the mysticism issue on this topic is, first of all, if that's the case, if a part of your consciousness survives in the sense of being quantumly entangled, right, and you die, those subatomic particles, like I was saying, are outside of the space-time continuum. They're basically vector particles, meaning that for the most part, they are not affected by gravity. Vector particles are not. Now, not every subatomic particle is a vector particle, like neutrinos are not. They have mass and are definitely affected by gravity, although not much. There's lots of them passing through us right now, and to collect them, people have to go way down into the bowels of the earth and then set inside of distilled water tanks with detectors waiting to capture one, and then sticking them forever to find any. But at any rate, there are vector particles. and you would presume that those are not affected by gravity. So if you have these quantum entangled particles, right, and if subatomically speaking they are still entangled, then because they're vector particles, they're outside of space and time because they travel at the speed of light because they're energy. And if they travel at the speed of light, that means they basically have no mass and there is no time for them, right? It's timeless for these things, which is why the universe lasts so long. So at any rate, so if there is a part of you that's entangled, then the first thing it's going to do is it's going to meld with the rest of anyone else who had entangled particles that died. Because it's when you die and you release that, it stays entangled, but it goes to the same place. Everybody's going to the same spot, right?
Or could that be stated this way? It all goes to the same energy level.
Yes. You could state it that way. But the main, well, we'll talk about this other implication in a second. So I just wanted to establish, I mean, because I want to stay in science right now, right? And you know, science, the hard science does talk about quantum entangled particles. In fact, one of the main issues in quantum computing isn't in trying to study superposition or qubits or anything like that. It's in trying to figure out how they can cool down an area to absolute zero. And the reason why is because they're trying to avoid the second law of thermodynamics. They're trying to avoid dissonance. They're trying to stop everything from vibrating. They're trying to cool the soup down, right? Enough so they can hold this thing in a superposition so it doesn't collapse until they're ready for it to collapse, right? They're going to orchestrate it with computers, right? And this theory is saying that your brain is doing that. But it's the same principle. That's what they're doing in quantum computing. They're just trying to get the shit away from the superposition. It's not much different in how the plasma reactors work, where they've got the magnetic, the magnetic bottle that they make.
Yeah,
with
they
strong
make a
magnets
large magnetic field to support the. That's what they contain the plasma inside of.
Yeah,
right?
because it's 5 times hotter than the sun and would
Yeah.
burn through anything if it wasn't in this magnetic bottle, right?
Really hot.
Right.
Yeah.
It comes, you know. So, if you know, so you're in this state presumably as a vector particle outside of space and time, and consider that when it comes to how you feel about anything, you know, how you feel about something, your proclivities perhaps, maybe, how you do things and what you're prone to do, right? Your idiosyncrasies, maybe, your choices.
Whether you're OCD or not. Or...
Yeah, a lot of these things, who you fall in love with in particular, are not in any way dictated by the conscience stream that would entangle cells and atoms in your neurons, okay? Those things are governed by chemical processes. Now, it is worth pointing out that chemical processes themselves are controlled by quantum functions, but how you feel and who you fall in love with, that's all chemical. That's oxytocin, dopamine, serotonin, and those kind of chemicals, right? It's like what foods you like, what flavors you like, what pheromones you respond to, who you fall in love with, why if you like hamburgers and don't like fish. So, oh man, I got a cold. So whatever existed past death in that sense is not going to be how you feel. It's going to be an intellectual situation. It's going to be your reasoning and how you figure things out. It's not going to be how you feel, right? So that doesn't go with you. And I just want to make that clear, because that's all chemical, and that dies with the rest of your chemical material body, which is not a vector particle, right? And your atoms survive that process and blend with other people's, and you'll probably maybe have heard when people or little documentaries or whatever talk about when you breathe every so many breaths, it's likely you've breathed an atom in the air that Cleopatra did. You know, I mean, that shit gets recycled constantly. So that's going to recycle. But I don't know. Again, we're talking about this entanglement process and how far does it go. We know it changes atoms, but we don't know what the process is. It's likely the process is subatomic if it's changing atoms, right? The tools are almost inevitably always smaller than the thing that they're working on. And that brings me back to this uncertainty principle. I also want to explain this. Again, I get to some of the point in a conversation like this at school or something, and people will say, well, wait, what are you majoring in? History. And then just...
Yeah, it makes perfect sense.
Right, exactly. Why are we this
totally
deep in this
it.
conversation, for goodness sake? But in my European Reformation class yesterday, it ended in a conversation about this theory, and the professor was like, I wasn't really thinking we were going to end this conversation in a conversation on quantum physics. But
yeah, because kind of what this is doing, this theory does, is sort of give a quantifiable explanation for individuality, for consciousness.
Yeah, and shows it being like kind of fitting like a glove with chemistry and how an individual would develop, right? So let's see. I want to make sure I covered. We were talking about the uncertainty principle. Sometimes I wonder how I don't get lost in this. Like, oh no, yeah, the uncertainty principle. I remember. Well, it's because it bugs me, right? Again, I'm not like an authority or anything. I'm not a teacher on this or nothing. But
you're just fascinated by the subject.
I am, and I hate it when, and I know as soon as I say this, somehow the universe will prove me wrong. Because even though nothing is personal that the universe does to you, there's certainly irony that it gives you. Anyway,
yeah, no doubt.
I'll probably be proven wrong. So, but I hate it when I watch a documentary and they're talking about quantum physics, and usually you don't see too many documentaries just on quantum physics, right? But you get to the part on a good one about it, right? And they'll hit you with, if you nobody knows anything about quantum physics. I mean, if you think you know anything about it, you probably don't know it, or it's stranger than real life, or it's stranger, like they really hype it up, man, as being like crazy thing, like clowns and shit, right? Like circus monkeys and stuff, like, not in a good way. Like it's just convoluting and confusing and crouched, and it's not, man. Couched, it's not. It's And I think one of the good examples is the uncertainty principle, right? Where people will say the very act of observation changes it. You'll never know. You can't look at it without changing it. And that sounds really messed up, man. Like, well, how the hell does that work, right?
Right. How do you effectively ever measure anything?
Right, on that level. And you don't, right? But here's a good example of it. I'm trying to think of a metaphor or a direct example. I always go with a direct example, but I came up with a metaphor that I thought was pretty good. So I'll do metaphor and then a direct example. So if you had a cup full of pencils, right, like on your desk, and you're trying to get just one pencil out of there, maybe there's like 20 pencils in it, so it's pretty full, right? It would be like trying to pull a pencil out without moving any of the other pencils, right? Your hands are so big that just getting down to get that thing is going to move other things out of the way, right? You can't avoid it, right? And if you only seen where that thing was when your hand touched it, by the time you would bring it back, the other things would be someplace else because you moved them, because you bumped into them, right? So directly, here's the example. It's the same thing in quantum physics with the uncertainty principle. So let's say you're measuring an electron, which we talked about earlier, that has a spin, right? Because you don't know where it's at. Then you measure it and you don't know where it's at. It's because the thing that you're measuring with conventionally is light, which is a photon, which in the quantum world is an energy-carrying particle. In electrochronodynamics, it's the energy-carrying particle, right? So for you to see anything, you got to hit it with light, and that light's got to come back to you or to your detector and say, okay, boss, this is where it was when I was there, right? When this light was there, this is where it was. And when I got back, here it was, right? But when it hit that electron, it boosted its energy up. It probably caused it to quantum tunnel into another orbit around the nucleus of the atom, which means it's in a different place, traveling at a different speed. So even though you measured it, by the time your information got back to you, it's like the Postal Service in the old days. Things had changed. And largely because you sent that photon in there to record it, and that photon jacked up the electron's energy level and made it quantum tunnel and change its speed and its direction. So
that doesn't mean it doesn't exist.
It doesn't mean it doesn't exist. It doesn't mean there's anything mystic about it.
Right.
It just means you bumbled in there with very large tools, knocked some stuff around, and came out of that job, and you can't really say where stuff is at because you knocked a bunch of stuff over in doing what you were trying to do. And, so by the time the information comes back, that electron's in a different place. And that's the uncertainty principle, right? On a quantum level, how do you get down to looking at it? What tools do you use? When all tools are made out of atoms and you're talking about looking at stuff that's smaller than atoms, how are you going to do it without bumping them all around, right?
Right.
It's not a mystery. It's just big versus small, right? But you'll hear the music. The very act of observation changes the reality. Yeah. It's like a bull in a china shop, man.
Right.
You're going to knock some stuff over and move things around, and you're not going to know when you come out how things fit back together because they're all smashed.
Right. No doubt.
So that's that. That's the uncertainty principle. I just wanted to talk about that because that's the thing. When we're talking about superpositioning and quantum wave collapsing and stuff, you're trying to keep stuff away from it. And because you don't want to be uncertain about it, you don't want to get in there with stuff that's big and knock it around.
It's funny because there's a lot of, I don't know what you would call them, like self-help gurus and stuff like this that have been purporting this idea that your mental, like, I'm trying to think how to explain it. They feel that if you continually they call it projecting or whatever, like project good energy, that then you're going to get good energy back, right?
It doesn't seem unsound when in 2014, one of the parts of OR theory that was proven was that these microtubulars do in fact resonate with the quantum fluctuations. Like, that's been the biggest news in this theory so far. So why would you not be able to communicate and send out and broadcast, or align yourself with frequencies coming in or whatever it is?
Well, if you can, does consciousness affect the orchestrated collapse, or is that just something that's going to happen, period?
It does. It affects the orchestrated collapse.
So then that gives credence to this kind of concept, then, that
I think so.
Your mental state, or where you allow yourself to sort of focus your consciousness, could have an effect on the material world.
Yeah, but
Yikes.
But it would likely be a deep thing inside of you, inside of your conscience, and probably would be just the sort of thing that things like meditation would help with.
But you said that feelings are chemicals.
Yes.
Though, right?
Yes.
So that's not part of this.
No.
So
nobody's mad in heaven.
that we know of anyway, right? So that being said, then that's not part of that's not part of this consciousness.
No, because animals feel.
They feel pain for sure, and they definitely feel
and they feel emotions.
And
They can be. Yeah, they can.
Anybody
feel.
that has a dog knows that.
Anybody that has chemistry can feel.
Yeah,
sufficient chemistry. I'm not suggesting that perhaps an amoeba can feel. He doesn't have the sufficient chemistry.
Right.
But as you get a higher order of biology, and that chemistry becomes available. But the height of it is that chemistry interacting with the quantum world, and this is not unknown in nature. Plants convert sunlight, photons, energy-carrying particles of the electrodynamic quantum theory, into energy, into food.
Through photosynthesis.
And which changes it into food, which they can eat. So.
Yeah, but okay, so I'm trying to peel this apart, right? Because,
and this is just the science. I'm yet to address the mysticism.
No, for sure. Okay, so let's just stay here for a little bit. Okay, so in this theory, then, from what you're saying, is that because feelings are a chemical reaction, and your consciousness is something else. Okay, and once you die, right? You don't feel bad about dying.
No.
You probably don't even feel bad about, you don't feel bad about anything, because
No.
that's gone. That's a chemical reaction that's gone, and all
No,
that's left is
you can logically, I mean, you can. There's only an extent to which you can feel bad. You can be aware of a bad situation logically, but you can't feel bad about
do
it.
you think memories reside in that consciousness?
Yes, definitely.
So then memories of those feelings would reside
Exactly.
in
That's
that
what I'm saying.
consciousness,
Like,
right?
yeah, like you could logically be aware of despair and understand how to relate to it or how to react to it, but you wouldn't feel it. For not just for that reason, but for reasons that when we talk about the mysticism part would be interesting too.
Mr. Smith, are you saying that the streets of heaven are truly paved with gold and all your worries and troubles will be gone?
Yeah.
Is that kind of what you're getting at?
To extent, yeah. You don't have any. You don't have any because there's not a frame of reference for those things. There's no feelings, so that frame of reference is gone. There's no likes or dislikes. That frame of reference is gone. There's no individuality. That reference is gone.
Yeah, I was going to ask about it. So, okay, so if there's no individuality,
and there's
then,
no time, no linear time.
if there was no individuality, what would be the frame of reference for memories then?
Well, they would exist. They would exist, in fact, within the geometry of the space-time of the universe, which is the very thing that this theory is saying is co-responsible for selecting the wave function collapse. So, that they would be there. Memories would just be, you would be aware of them. You would be aware of a lot of things, more than just your memories. You'd be aware of everybody's memories, because you would lose your individuality, and a part of losing your individuality is gaining everyone else's. And you would know everything they would know, and they would know everything you would know.
Well, if from what you're saying though is that time is immaterial,
It is. It's not linear. It
you
exists,
wouldn't
but it's
just
not linear.
know all the information that everybody
It would just
knew.
be there
You would know all the information
that there was to know.
ever to know.
Yeah.
That,
But that wouldn't mean that you would know all experiences. You would know all information there is to know, but you would never know all experiences, because experiences arise from the veil of linear time travel.
but that leads the idea that then there's individuality.
Only in the sense of an individual and time travel and chemical reactions. Okay? So maybe now's a good time to bridge over into this metaphysical part to talk about these things, right? and again, this is one of these situations where I'm not sure exactly where to begin, but I think the first place I'm going to try to begin with is the science, such that it is. So when it comes to what might pass for reputable testimonies on the afterlife, you're thinking of near-death experiences, like where people die in the hospital and then they wake back up and that sort of thing, and they say that they've had an out-of-body experience and went toward the light and that sort of thing. People who have been reincarnated, if such is true. Again, if such is true anymore, then near-death experiences are true, right? And people who put on the God helmet, which is a device that is like a motorcycle helmet with magnets put into it that affect a certain part of your brain, and people who take DMT, which is a drug that can be manufactured in a pharmacy and is found in all living things, all people, all animals, all plants, and is in your brain right now. And those people who have ingested large amounts of DMT, which is also proposed to be responsible for dreaming, people who have had near-death experiences, people who have had reincarnation experiences, all of these people have...
You mean, when you say reincarnation, they were in a previous life,
Yes.
They were somebody famous.
Yeah. And let me address that, because it's weird,
Yeah, I want to know why. How come nobody?
Why is that in there, right?
Right. Why isn't anybody ever just Joe Schmo? In a past life, they're always like Catherine the Great, or they're always somebody powerful and famous in a previous
Well,
life.
it's because they don't know what they're talking about. But let me tell you, so it's funny, man. Like,
that was obvious.
when people talk about near-death experiences and the experience that they had, like an out-of-body experience, for instance, people don't just say, "Okay, you're full of shit," right? They consider, well, okay, you were dead for a while, you know. When people talk about tripping on some kind of a drug of any kind, and they said, "Yeah, dude, I totally was hallucinating," no one says, "I doubt that you were hallucinating." Like, they believe that these guys seen something.
Oh, sure, right? Yeah, absolutely.
Right? When you start talking about people in reincarnation, immediately people are like, whatever, you know, you're full of shit right there. You know, it's like, okay. And I'm not trying to justify it either, right? I hate the fact that it's a part of this, to be honest, but it is. So there you have it. And the best research done, factual research done on reincarnation has been done in a research institute in Canada. I can't remember the name of it. And it's all about kids who were 4 years old or younger, exclusively. So when I heard that right there, I was like, what the fuck is up with that, right? That's weird, right? Because like you said, the only thing I'd ever heard were people who were great emperors and shit, you know, and whatever, right? That's because that's crap, right? And to spend a little time talking about this, maybe, if, you know, and again, check these things out. I think I might even have links I can send you. I never even sent you my thesis from before, but I need to do that too. But this place, basically, their research is that these kids have verifiable stories, okay? And it's hundreds of cases. And they've got some really good ones. And the one that I seen like, I think 3, but one was really good. And it was about this kid, and at the time he was about 6 or 7 when the documentary was filmed. But they were talking about when he was like 4 years old and stuff, and 3. And they said every night when he, like, from the time he was like, just when he got to be about 2.5 to like 4, all the time he was waking up screaming every night with bad dreams. And as he got older and was able to articulate and say words and stuff, he was burning every time. This is why he was screaming and waking up. And then as he got older, he talked about being in an airplane, crashing into the ocean, and eventually, by the time he was around 4, he was able to actually give the name that he seen in his dreams on his shirt in the plane, and ship numbers that he seen ships when he was crashing in his dreams. And they looked this information up and found out that there was this dude that was in this battle who died with this plane going down in the ocean. It was all verifiable. And this is like one case out of like 50 that were like really solid. And they had hundreds that were, you know, just couldn't be verified, but fell into the same category, you know, because they involved non-consequential, boring shit that didn't go down in history, right? That no one knew about. But a few of them did. A few of them somehow were verifiable, right? So this information would be hard to get from young kids having dreams, right? So it was fascinating, and they were talking about it, and they were saying that up until the time of about 4 or 5 years old, when you do a brain scan of a small child, a baby, or an infant, the whole brain lights up. There's neuron activity in the whole brain. And the classical view of this is that the brain is not finished forming, that it's still growing in this way at this age. But these people were speculating that what it was is that when all the neurons were firing, it's because it was still freshly plugged in to what they consider to be the afterlife, which for this conversation and for us would be that situation that we described with entangled particles, right? Because remember, they are only entangled in the subatomic and atomic parts of the cells of the neurons in the brain, right? So the fact that you would do a brain scan and the whole brain would light up with all the neurons active. I mean, normally when things are growing, they start small and they get big and more complex. I mean, that's the general classic theory, right? The brain gets complex and then self-awareness arises. And an infant could arguably be no more self-aware than a monkey, right? So they theorized that these people were still in touch with the afterlife, and that hadn't been had not been cut off, and that after the age of 4, when you do a brain scan on somebody, the part of the brain that's glowing, that's active, is the part of the brain that's being used. It's more like it goes from a lantern to a flashlight, a spotlight, right? And it focuses. And then presumably they figure it has to do this because you're interacting with the world, you're being bombarded by stimuli, you're trying to process it, right? So you have all these different functions of the brain working in tandem to do these things, right? Again, this is this classical, here's the machinery of the brain, and if we get enough of it, something great's going to happen, right? But so it was just very interesting that these kids had, that all kids have the brains like that until they get older, and that some of these kids were having these dreams and these abilities to verify other people's lives, if not their own, right? And a couple of the reasons why these kids were brought out is because this institute was contacted by their parents. So, like, not only did they have kids that had information that was verifiable, where the parents found the information and was like, holy shit, what do we do with this, right? Oh, look, there's this place in Canada that specializes in this, right? So a couple of parents made it there, and they were able to talk to these kids, and they asked these kids these really crazy questions, like asking them to remember that transitionary period between their plane going down, like this one kid's plane going down, and what happened after that. And this one kid's story was that when he died, he seen everything that happened, and he left that place, and he lost his identity, and he was in a place, and he didn't know how long he was there, but it was the only place that he could be in the source of everything. And that's how this little kid's like, he's like 6, right? And he's just saying, it was everywhere. It was everything, right? And and they said, well, how did you come back? And he said, well, I picked my mom and my dad. And he said, how did you pick them? And he says, I just thought they'd make good parents, right? And he even said that when he came to his parents, that they were in a hotel room, and described the hotel room, and that's where these parents had went to, like, get pregnant, right? Like, they had planned it out, they were married, and they were trying to get pregnant, right? And when I heard this, man, I thought, wow, if your intellect survived but your feelings didn't, how would you select to come back into a linear time if you were outside of linear time? You could go to any time, any place you want it to go to, but you wouldn't have no proclivities as far as feelings, right? So you might be looking for a good set of parents, right? In fact, you may not. You might be looking for a parent that is going to have a baby that's addicted to a drug or deformed. Yeah, because maybe you've lived over and over and over and over again, right? Outside of time, how many times have you come back? You really don't know, because there's such a difference between linear time and nonlinear time, right?
And does because what you said before now, I'm just trying to make sure I'm keeping all this straight, right? Because this is fascinating as shit, okay? You do or do not maintain your individuality.
You don't.
Okay, so first, let's put this down. This is all entirely speculation. This is just like a theory, right?
Yeah.
There's a lot of science
Yes.
that kind of bubbles under the surface of all of this.
Yes.
But this is just somebody kind of taking a trowel and smoothing it all over and saying, look, it might all fit together
Exactly.
like this, okay?
Yeah.
So
And
let's say
that's why we were
right?
talking to the mysticism when you said,
Yeah.
how does this all kind of fit together?
Okay, so do you or don't you, in this theory, maintain your flesh, you get hit by the proverbial bus, your quantum entanglement, then you lose all feeling, but then your quantum entanglement takes you to some energy level that puts you on par with every other consciousness that's died, that's
Yes.
physically died, okay? If you're at that same end if you're at that same energy level, though, you would necessarily, I would think, lose your individual consciousness,
That's
right?
what everybody says.
So how does this kid then remember an individual consciousness making the decision of picking parents going, because I thought they'd be good parents? I don't understand how that works. How's that add up?
Well, he, you know, it's hard to say. It's hard to have definitive answers to these questions that you ask, right? I speculate that the process of coming back is much like the process of leaving. That when you lose your individuality, when you sink into the group conscious, for lack of a better word, or the energy level, when you extract yourself out of that, you gain a little bit of individuality back, at least in the sense that you're able to make selections for you, right? You never lose the ability to make the choice. But at some point on the way back, you have to have enough individuality to be choosing for yourself, right?
Is there a possibility that it's,
I suppose
is it multi-layered? Is it because we're making this assumption that everybody, quote, returns to the exact same energy level, and okay, so that would mean the same energy, frequency, and vibration, right? The same exact. But all of this is a theory, so we don't even know if that's the case, right? It could be like
it's a theory that has a lot of observation to it, you know, like the idea of entanglement and stuff.
Yeah.
You know, it's and really, you know, again, I think it's, for lack of having any science to back these speculative, mystic parts of this, I would just simply say that it's likely that when you start coming back, you're extracting yourself out of that group consciousness, that energy state, and you're coming back to this, right? Because you're literally going to be transferring from non-linear time to linear time, and you're going to be transferring from a vector state back into mass, right? You're going to be combining that, at least. You're going to be combining that vector state on a quantum level with a new body that's being hosted inside of a person, right? So you must come back with enough individuality, or perhaps by coming back to a linear time stream, you can be individualistic enough to make a decision for yourself, like, I want these people or I want these people. Now, once that process...
What if it's just as simple as superposition? It's you're both an individual, but part
maybe
of
so.
You know what I mean?
Yeah,
at the same time.
That's a fully functioning possibility, I would say. Absolutely. There's a lot of possibilities. I'm only going with this because it's like the simplest at this point in this mess of stuff, right?
Fair enough.
Assuming you can just come back and do this. And I want to point out too that it's not just this one kid that we're talking about with this story, right? Aside from and really quick, to address what you had said about how did he remember a past life? Presumably, the reason why all of the best cases of reincarnation deal with kids who are 4 or younger is because while the brain is in that state of being fully active, that's the only and best time that they're going to have any connection with any memories that's in that group consciousness, that's in the Planck length space-time geometry, right? That's the only way. And then after that certain stage of development, the link, what's been extracted out of the group consciousness that is now the individual entangled energy that is you, is now linked to specific chemistry. And DNA is just as, and chemistry is just as specific as energy frequency. I mean, energy frequency and vibration is specific, but deoxide ribonucleic acid gives rise to, so these things get linked together at some point.
Specific.
And then at that point, they are an individual. And you see this with people when they get old enough from being like a baby to being able to walk and talk suddenly, and they start getting their proclivities and stuff. It's because that bond is fully linked now. And a part of that is that the brain is putting a veil over these neurons. It's deadening them and just using the ones for this, right? Because it's linear time now, right?
Just for actual stimuli, that
Yeah.
physical stimuli,
Yeah.
or physical world stimuli.
And more importantly, the difference between nonlinear time and linear time. Like, for instance, there's a lot of differences that you don't really think about, right? In nonlinear time, you can't have any games of chance. There is no such thing as chance, because chance is dependent upon time. And if time isn't going in any direction, in any one direction, backward or forward or whatever, nothing's going to happen. It's a stasis, right? And if you don't have individuality, there's no reason to talk to anyone. There's no reason to wonder about anything, because nothing's going to come out by chance anyway in that state, right? So what else about... No, in nonlinear time, you're never going to have chemical reactions. You're never going to feel anything in that state, in that vector particle energy state, because you can't, because those feelings, as we discussed earlier, are based on chemical processes, meaning that there has to be mass in the universe that interacts on some level with the quantum world for those things to even happen to begin with, right? So if you can't feel anything, and there isn't no chance to be had in any event that occurs, right? No quantum effects like that, and there's no time, and there's no individuality, how would you give any context to you? No matter what you were or who you were, even if you were a bunch of people, you're still
right.
one. And how is there even context, and whether you're a group, collective, or one thing?
Right. That's kind of what I'm getting at.
Right.
But obviously now, and here's an idea, right? Are we all just pieces of the same consciousness?
I don't know.
In separate iterations.
I don't know.
You know,
but I do know that if you were going to ever have any context to anything, you would have to pre-force go to linear time. And we just talked about what nonlinear time was like, right? Now, the difference in linear time is, the main difference is that because things happen in sequence and are dependent and cascade, variables pop up like flowers in the jungle everywhere you look. Variables. No one can account for all the variables, right? And that's important, because when you were asking what is it that makes the brain go from having all the neurons active to just spotlighting, it's probably that. It's probably the idea that every day we as humans in our existence are dealing with these many variables, everything dependent upon everything else. The whole thing of like the butterfly moving and changing weather. It's not just that, man. It's all mass and all motion moves all time, and everything is in motion, right? So to deal with that shit and to have the chemical reactions, that's probably why your brain starts focusing. That's probably how you lose that connection between that other existence and the times and the lives before, that you may or may not be embedded in the geometry of space-time. You lose that connection because you're really heavily embedded in linear time, and shit's happening on the fly, and you're living life.
Well, and let's be honest, if because life is painful, life is irritating, life, it's aggressive.
But in such signifies your passage through it.
And if you knew, like, you had this cosmic connection to all of this other, and that there's no pain, that there's no irritation, you'd just be like, oh, well, fuck this.
Yeah, and you might, that might be the case. But think of the inverse of that thought, right? Which is when we were talking earlier about when you're coming back to put yourself in this linear time stream, because you have no, okay, and this is what I was talking about earlier. The assumption here is you'd want to come back to here, to Earth, to linear time, because in the other state, remember how we were talking, there's no frame of reference, there's no way to show progress, there's no way to do anything, right? Like, you are everything, and everything is you, and all time is now, and then everything is right there, right? So I would think, maybe I'm wrong, maybe it's just my opinion, but I would think the only way that they could add to that state would be to go into a linear time where they could have experiences. Now, see, we were talking about those experiences on there, right? That, what were they called?
Oh, they had the
phenomenal
right,
experiences.
phenomenal experiences. Yeah,
where you're
phenomenal
connecting,
experiences.
making these connections and stuff.
Right.
Like the only way you're going to get that is here. You're not going to get that in the other place. You can't have those kind of connections.
Because you are a phenomenal experience at that point.
You're every experience and every one and yourself at that point. There isn't no phenomenal because there's no separation between you and the outside. So that state doesn't exist, right? So to have these connections like this, you would have to be in a linear timeline that made veils that had chemistry reactions and where things like chemistry and frequency of energy interacted and did arise individuality, not just in a person, but in every event, in every moment. The moment that we're having right now, unrepeatable, ephemeral, because
of time.
Yeah. And so if you, the only way to add to the other place is to come here and get some of those experiences, those phenomenal experiences.
Yeah, but again, time doesn't exist there. So every experience that's ever happened, is ever possible to be happening, exists there all at the same time, right? It's all
not necessarily, because in that state, that's a state of non-matter, of vector particles and timelessness. So it's not likely that it works that way. When you're there, you're definitely separated. You might be aware of everything that happens in a time stream when you're there, but you won't experience it. You know about it, but you won't have that phenomenal experience. You won't have that connection. It won't be meaningful to you because you knew it before you ever looked at it, before you ever pondered this thought. You had that thought. And you knew what you did with that thought. You know what I mean?
So consciousness is kind of addicted to the physical experience of emotions and stuff. It's kind of where you're
in linear time.
And linear time, because it's the only place you can have them, right?
It's the only place you can have meaning, frame of reference, feelings, connecting with the intellect in that way. It's I suppose the equivalent to, like, if okay. So let me back up a little bit. I was saying earlier that it's not just us talking about reincarnation or talking about this kid, right? This is what this kid says, right? But there's also people who have had near-death experiences who also talk about their journey. They say that they go out of their body and they see people working on them and sometimes calling death, and they travel sometimes through the earth or through the sky. They eventually start passing people that they recognize, right? Maybe people coming back to this, extracting themselves, right? That they recognize coming back, that frequency, that energy. And then they go to the light and they describe the light as the source. And when people describe it as the source and they ask them for clarification, that's when it breaks down. And people will say it's the source of all love. It's the source of all math. It's the source of all matter. Why is it the source of everything that you can define? Possibly because it's outside of linear time, right? It exists in that state that is eternal. No time is passing, right? So it is literally everything. In that state, it is everything, right? And that's what their descriptions are. Now, if you take people, now we've talked about the reincarnation people, we've talked about people who've had near-death experiences. Let's talk about a third category, the people that have taken large amounts of DMT. DMT is a chemical in all living things, is potentially responsible for causing you to dream when you sleep at night, perhaps your creativity. But when you take it in larger dosages, you have these earth-shattering experiences and epiphanies, and inevitably, and there's a documentary you guys can watch if you're listening to this on Netflix. It's called DMT, the spirit molecule. And the people, when you listen to them talking about it, they say the same thing. They say that they have an out-of-body experience. They meet people that they know. They lose their individuality. They go to this source. Some people in that case described it as like a city, and that you could tell because there was things happening and there was like pieces and stuff. I mean, it's very abstract and bizarre, but everyone's hitting in that same ballpark, right? People are going to the same spot, whether they're reincarnating or dying or tripping on this drug. They're going to the some same spot in their head or someplace else. I don't know. Another example, like what is this, fifth or fourth example, maybe, is people who experience wearing the God helmet. The God helmet originally was a motorcycle helmet that they drilled holes in and put large electromagnets in.
Yeah, just the helmet.
Yes.
Nobody's head was in it.
Right, right.
And they drilled the holes.
Right, yeah. And so when they turn these magnets on, these people have all sorts of effects. The more stronger effects are the people who have out-of-body experiences and talk about relatives being in the room and ascending to a source and things like that. Under lower settings, it seems to interfere with the idea of sleep paralysis, like when people don't have that engaged in their brain correctly and they sleepwalk. And this is something that's been experienced throughout time with legends of the succubus and of alien abductions too. These things are all connected in that way, in that weird way. We can talk about that some other time. But my point is that there's chemistry, whether it's produced by a dying brain, or taking DMT, or having your brain hit with large amounts of electromagnetic energy. There's a certain chemical occurrence that occurs. I don't know what it is, but once it engages, it allows you to engage all those neurons and start connecting with that other place. And the reincarnation documentary was separate from the DMT documentary, which was separate from the OR. But I happened to watch them all in the same month or two. I couldn't really help but make the connection. I'm like, really, could it really be this simple? Could it really just be that this is how it works, and you don't really need a God, and you don't need a heaven, and you don't need a bureaucracy, and you don't need anything, and all spirituality came from mistaking psychotropic substances because they themselves will have DMT in them and cause you to have this connection, right? I mean, maybe they are what we talked about that they are, except that this place isn't governed by any. It is, in a sense, governed by one almighty being that's outside of time and eternal, but to a large extent, that's you and everyone else. And when you're there, you get really bored and you really just want to come back here. I mean, what if it was this place that we live in from day to day and toil in that was heaven?
And it's funny because as you're explaining this, that's what's ripping through my mind is I'm hearing I guess it all depends on the way you read it. Okay.
Mm-hmm.
But I'm hearing a lot of commonality with descriptions, ancient descriptions, things like that. Cause this is something that physical man has always tried to quantify, right? We've tried to record this. Some of the earliest things that we've recorded have been about these kinds of subjects, right? As a species.
Mm-hmm.
So we're always trying to quantify this. And when you like you said, when you kind of take a step back and you say, okay, listen, somebody's had a near-death experience that has this explanation of, this giant oneness or this, the source of all information or the source of all energy or the source of all love or whatever. I mean, you can kind of see that, I'm the alpha and the omega, the beginning and the end, like you kind of get like.
And it's not that much difference between the cycling between matter and energy, between matter and vector particles. And, when we were talking about it with people that take the DMT, when they come back and they ask them how long they've been there, they say that they can never tell, right? Much like when you're dying or put out with anesthesia or whatever. But if you were coming back, and we were talking earlier, and I said, so imagine how many times this is back to the conservation of energy again. This is back to Susskind's that there's no energy being lost in the vent horizon of a black hole. It's being stored two-dimensionally. It's what gave rise to the holographic principle, right? So
you're going to have to explain the holographic principle.
Okay. Okay. So the holographic principle, maybe some people have heard, hey, we might live in a holographic universe. Isn't it strange? The closer we focus in on it, it just kind of pixelates out.
This is real, the Matrix kind of shit now. This
Yeah.
whole concept of living in this holographic.
Yeah, but again, these documentaries dress this stuff up to make it all sound way cooler than it probably actually is, but it's not improbable. It's just about as probable as the Matrix movie itself. So go watch that instead. But but
Keanu Reeves was excellent in that. I'm sorry.
yeah, wow, I like him as an actor in just about anything. I don't think I've not disliked him. I mean, I certainly don't judge him by Bill and Ted's Excellent Adventure, given the.
I'll take him in that than all them damn chick flicks that he made.
Yeah, well, I mean, I've seen those.
The Lake House with all them. Ugh.
Oh, what? Keanu Reeves, man.
Yep.
Wow, I just got a picture of his face in my head and nothing else. That's all I got. Where were we at?
Well, we're kind of talking about how, you know.
Oh, no, I remember. Holographic universe. So, you know, the idea to this is that we live in a simulation. It's like a computer simulation, and we're figuring it out. And another part of it is that when we were talking about the uncertainty principle, you know, how you're moving stuff around by the observation, which is another way of kind of saying that it pixelates out. Like when you're looking at a picture on your computer screen, you just zoom in too close and it just pixelates out. So they were looking at that aspect of the uncertainty principle and saying that when you got down to that level, it was pixelating out, and that was much like you were breaking through the simulation, the computer simulation. And in my mind, that's a lot of construct and a little science, right? That's like an idea of science, and then you went ahead and painted this whole picture that there's this entity that's made this construct and is running this construct, and thus there must be a meaning and an end to this construct, and then you're right back at Hitchhiker's Guide to the Galaxy, and your plan is going to get destroyed by the Vogons before it runs its simulation, and no one's going to know except for the girl in the diner. So at any rate, that's probably not the case. Occam's razor, that's probably not happening, because then there's all sorts of other shit that would go along with that. But the crux of the matter before that circus started going on, was the conservation of energy. When we're talking about these alpha and omega and stuff, you're talking about the conservation of energy. You're saying that shit can bounce around. It can be different frequencies. It can come in flavors. It can come in colors. But it ain't going anywhere.
Well, and it kind of adheres to that concept that it's never gained nor lost.
Yeah,
it just changes state. You know, like there's no beginning or end to energy. It's just constantly changing.
There's
state,
poles, maybe, but that's all. So someone came along, Kip Thorne, and said, "Well, what about a black hole, man? Like, once something goes through the event horizon of a black hole, it's gone from the universe. You can't see it. Light can't escape. So for all purposes, it's gone. That information, lost.
Like a super shredder."
Yeah. And people were like, "Well, I don't know, man. That tastes bad." It's like
the Langoliers.
Yeah, like an old marshmallow out of a bag, you know. It's like they're stale and stuck together. Like, gosh, how's it stale and chewy at the same time? This is terrible. So they didn't like that. So Stephen Hawking, he's a pretty brilliant guy. And this is my thing about math. This is why sometimes I don't trust math, because you can math yourself right into a really good plausible explanation where the math completely works, but just isn't right. And that's what worries me sometimes about people who come from a pure math point of view. So Stephen Hawking approached this problem in that way, and he came up with Hawking radiation. And you may have heard that term because that was the catchphrase, just like the God particle was for the Higgs boson, but it was a Hawking radiation. And I'm sure he felt good because he was able, you know, he got that named after him. That probably was cool. But the whole idea was that he was saying that when you get near to a black hole, before you approach the event horizon, everything is shredded into gamma energy, which is the highest state of energy, and then passes through the event horizon.
The event horizon is the point at which no return.
Yeah.
Nothing's going to come back out. Even light can't get past that at that point, right?
And surrounding that is an accretion disk, which is all the matter that's being pulled into that as it's getting pulled toward that event horizon. It's getting shredded by the gravity waves. And in thus being shredded, it's shredded into gamma energy. So when supermassive black holes at the center of galaxies feed, you can see them by the huge burst of gamma energy that they release. We used to call these things quasars, and we thought they were a whole different thing until we realized, nope, that's just a big, giant, massive black hole eating.
And that gamma radiation is it's that
Eating.
process of it eating
Yeah.
and destroying matter,
Yeah,
right?
yeah, because it basically heats it up to the highest state that energy can be in, which is gamma energy, and then heats it.
And that's the only thing that can escape from a black hole. Is gamma
No, nothing can, even gamma radiation can't, once it gets there, because gamma radiation travels just as fast as light does, and light can't escape. So no, it can't either. But what Stephen Hawking said was that when a black hole wasn't feeding, that over time, due to the spin of it, the singularity at the center of the event horizon, the angular momentum would spin off Hawking radiation, and the event horizon would slowly evaporate down to the singularity, and that the information would slowly be released. And then they mathed that out to the point where they said, no, that's probably not what's happening. And this guy named Susskind came along, and what he said was that what was going on was that, how we talked about mass creating such a large bit of gravity that slows down time. He's talking about space-time being connected together like that.
Yep.
He said, well, that there's such massive gravity going on at the point of the event horizon that what's happening is that all the information that goes into the event horizon is actually getting stuck on the surface of the event horizon and becomes two-dimensional, that it gets so flat against that surface, that event horizon surface, that it becomes two-dimensional in qubits. And there's a certain amount of space that qubit informations would take up on a Planck length. So once they figured out what that was, they figured out that all three-dimensional information could be represented two-dimensionally. And if that's the case, then that looks like that's what's going on. It looks like shit's getting stuck to that, and that's it. We're not losing any information. We're not losing any information. It's just getting stuck. It's still there. And if you could turn off the gravity, it'd be released.
So it's not like a special gateway to another place in the universe or something like that.
That
like
was an Einstein-Rosen bridge. Yeah, and I believe that was come up with as an explanation for the information paradox. Like, where does the information go? And I think that the work that they did on that was due in part to them trying to figure that out. Like, well, where does that go? Well, maybe if you twist space-time enough, you'll get a hole, and it will rip a hole in space-time, and you'll go somewhere else, right? To use Carl Sagan's words.
So this is where this kind of gets tasty, right? Okay, so we scienced the shit out of this, right? Or you've scienced the shit out of this for us. And said, look, there's, is this a theory? Yeah, this is all a theory. There's a lot of science, you're saying, that kind of supports this as this theory. However, there's, there probably will be no way of ever knowing for sure, right?
Well, possibly there will be. I mean, we've built the Large Hadron Collider, which is the biggest machine on the planet, and it was able to discover the Higgs boson, which we were talking about earlier as the force-carrying particle and the chronodynamics of quantum physics. And they were able to discover it. It was a theoretical particle until it was discovered with that. And I believe one of the last big things that it was testing for was to see if there was other dimensions curled up smaller than a Planck length in the space-time geometry. And I haven't seen where that went yet.
Right, sure.
There's a lot to keep up on, man.
Well,
and being in school too.
So there seems to be this really interesting convergence taking place. And that's what I'm saying. Kind of where this gets tasty is where it gets fun is when you start speculating about, okay, what does this mean? And things that are ripping through my mind are things like the Akashic record. How that there's this record that you can, metaphysical record that you can tap into, that holds all the information for the universe ever, and that inspiration is theorized to come from there. I've seen it explained that like Einstein used to force himself into like some like dreamlike states, and he would do his, what he called those, his mental
is mind models.
Mind models.
Remember we were
stuff,
talking
right?
about them on my thesis,
Yep.
how important those were, and you know what it is? It's likely that these people are using just a little bit more neurons than the average bear, so to speak. You know what I'm saying?
Well, okay, so is this one of those things? It's not. Is it like an urban myth that the grooves in Einstein's brain were actually deeper than the average humans? I've heard that before, but I don't know that it's actually true. It might actually just be an urban myth of some sort. But I wonder then, does the physical geometry of your brain then could have an impact on it because of the amount of neurons and things like that?
It probably not on that scale. It shouldn't, because
not with consciousness. Maybe with maybe with intellect.
Maybe I don't know.
The ability to process outside stimuli,
possibly,
and things like that. But that's not really what we're talking about. We're talking about that consciousness sort of exists
in and outside,
outside the individual, right? Yeah. But so that being said, like I said, these concepts of the Akashic record, that we're all connected, everybody's one, that's all sort of supported by this theory.
It's not that this theory doesn't hurt any of that.
No,
I mean, it doesn't go and apply in the face of that or anything.
It does. I mean, I guess where it starts to probably struggle against secular religions is in the concept, however, though, that what you're saying is that there really isn't anybody driving this bus.
No,
there is no conductor, so to speak.
I think that, but I mean, I think that this theory is so obscure and hard to understand, and the implications even less thought out, that no one's paying attention. I don't know what other people are thinking or saying, but this is what it implies to me. That implies a mechanism that's natural and could exist without there being a God, and would be fine. So I don't, I mean, but it's so far out there in everything, even the science, that I don't think it's a threat.
I don't know that it does. I think all it does is it eliminates the thought of a sentient consciousness, like that there's another consciousness.
Well, unless that is part of you. I mean,
that's what I'm kind of getting at. I mean, if all consciousness is the same thing, then then even in religions, though, they there's religions that have.
Well, the Jewish religion thinks that the being close to God is the best you can get. So. In a way, they're saying,
that's kind of what I'm saying, and then they'll say, well, God's in all of us, and that kind of thing. And what are they saying? They're kind of saying the same.
Gnostic religions were like that. Even humanist is like that. So I mean, it doesn't really go against any religions or anything.
That's kind of what I'm getting at.
Sounds a lot more like science fiction, and we talked about the science, and we've talked about.
Wait, it does, but it doesn't. It only does because of the method by which you're quantifying it. That's the only reason it sounds like science fiction.
Mm-hmm.
But kind of everything you're talking about, though, if you were to take and use more secular kind of religious terminology, it wouldn't sound like you were talking about science fiction, okay? It would sound like you were talking about a religion.
Yeah. It probably would. When you were talking about where your head went with the implications, because we talked about the science part, and we've talked a bit about the mystic implications, right? My mind went to a totally different place when I was thinking of all these things. The first thing I thought of was, wouldn't it be great to write like a trilogy, a 3-part novel, where the first novel opens up with a guy who is a psychotic killer getting gunned down by the cops, like in the 70s, and you have this really weird passage through the book that's very much unexplained, but it's just his experience of losing his identity and going to this place, right, and coming back. But because he was a psychotic killer and his brain was messed up, and because of that connection for individuality between chemicals, linear time, and vector particle energy, it corrupted his frequency. And when he uploads and comes back down and gets into another body, he corrupts the brain of that body, making another serial killer. And that it explains why there's serial killers in the world, because they were corrupted at some point. Their brain was corrupted, which corrupted the frequency, and the frequency corrupted the brain, and the cycle started, right?
So Jack the Ripper and Ted Bundy was the same.
So, it had the same issue,
guy.
same problem. It was a space-time problem. And so, you have the book being majorly about this killer, and it's a straightforward kind of a crime novel with just a weird beginning, right? And then he gets gunned down at the end of it again, and he goes back through the process. But you find that when he goes back, that he's now corrupted the whole conscience, right? The whole conscience outside of time has taken on a darker aspect. So you write a book about that, right? And then you end up writing a book that ties that all up. I mean, that's kind of where my mind went, was the implications like that. Like, how could that system be corrupted in a natural way?
Well,
which is probably a bad idea.
No, I get where you're coming from, but feelings are chemicals, right? Those don't transfer.
And you know how they describe most serial killers as being like they don't have any of those feelings, and they're really disconnected, and they just see
very
people
narcissistic.
Yeah, they just see people as tools and a means to an end, and that would be because of that, because they've got this brain problem that's caused by reloading down into a body with a corrupted frequency that corrupts the brain and disengages that aspect and causes this problem to happen. I know, right? It's a bit crazy for some kind of a book, but that's just where my head went with it.
I've seen a lot of this stuff because it fascinates me, right? I mean, I'm a big fan of conspiracy theories, of alternative theories on anything. I love to hear, I think a lot of it's batshit crazy stuff, but it's interesting to me how people get there.
Mm-hmm.
Like come up with a conspiracy theory and how they link all the pieces together, and
I like that too.
And then a lot of times, I'm surprised a lot of times at how many conspiracy theories turn into be like, that's for real shit, like,
because people are putting lots of thought and science into it, and they come up with some stuff.
You get enough people thinking about something, right? It's kind of one of the things. But so I've read a lot about different religions, different philosophies, and I'm a documentary junkie and stuff like that. And I've been hearing now for some time that there's a convergence that's taken place between physics, specifically quantum physics, is what I heard talked about the most, and spirituality. That there used to be a clear definition between science and religion, so to speak, right? And now that's not exactly true anymore. There's sort of starting to, and obviously not everything. Okay, I'm talking more at the higher level kind of stuff.
Well,
it's sort of confirming some of the things that some of these religions have been trying to tell us for centuries.
Far futurists will talk about transhumanism, where you're combining the ability of having essentially unlimited space for a lifetime of memory, and like in a hard drive, and the ability to make composite components like buckyballs and things like that, constructs and stuff, and the computing power that we have, and the idea of AIs, all of that stuff is leading to a probable future where we're going to be able to manipulate a lot of things about ourselves. We're going to be able to manipulate our chemistry and our body and our
CRISPR with DNA. I mean, that's already happening, right?
Right. Yeah. I mean, so much is happening. We're on the threshold of a future where we can literally remake our image in whatever fashion we would choose to do so. I mean, we're talking about the far future, right? But when you're talking about computing power and computing space and material constructs, and then you're getting into things like quantum entangled computing, you're talking about being able to recreate those very constituent mechanisms that create the individual, that combination of the quantum flux and the chemical flux and the veil of linear time, right? You're talking about being able to recreate those conditions as you transform into transhumanism. And once you've made that hard takeoff, you really do have to question what it means to be human. And Emily Durkheim is an anthropologist that done studies on religion, and her conclusion was that religion was completely a social construct and was completely human in nature and really had nothing at all to do with the supernatural, right? It's a human invention for humans, and that's it, right? When you get to the point where you can change the definition of who and what you are, where do you go for religion? How do you get the idea of a creator when you're obviously that creator and you can recreate your own body or your own mind or your planet, or you can make a Dyson sphere, or what have you, right? Like, where does your religion go? Where does your higher power go? How can you conceive of a power higher than the manipulation of energy and matter in your universe? So the idea of transhumanism is something that's potentially on our future, and it will be a point that we're not prepared for as a biological species. It's, like when you talk about Moore's law and technology increasing, like, it's going to happen to a point where we're going to have to set new definitions for what we are, because it's not going to be what we were.
Wow. Well, all right then, man. So some deep thoughts for tonight. We're coming up here on 2 hours, and
Oh, wow.
this was
It went by quick.
yeah, it was fascinating as shit. I know you've been.
Oh, wait, I wanted to say one more thing real
Yeah,
quick.
go ahead.
When we were talking about how often that it was possible that somebody could have died and went to that one place and then came back here and died, and back and forth, back and forth. On one of the re-entries, if the idea is to go to a place where you can have a frame of reference, a linear existence and all that, to bring back to the other place to make it something more than what it was, you're going to want new experiences, right? And at some point, you will have had the millionth time of looking for the best parents you could find and the best situation you could find, and people who are in love, people who are planning on having a baby. And you know what? Maybe I want to try poverty this time. Maybe I want to try what it might be like to be a disabled person. Maybe I want to feel what it might be like to live 4 months and die of a brain injury. Like, I know this is a possibility or likely to happen, very likely, and I'm going to do this for the experience, because once you go in, the veil's on and you don't know. Once you're out, the veil's off and it doesn't matter, right? So going in, you could see yourself committing to that. And I always thought how interesting it is, because when people have kids that are born deformed or hurt or something, around here at least, people are like, oh, why would God let that happen? Or people, oh, it's not God, it's the devil causing it. Or, there's always some sort of theological implication because people feel bad, right? Well, what if the explanation was it was intended? What if it was just part of life? What if somebody chose willingly to take this position to make whatever difference there would be for it and anyone else that's connected to that person in that situation? It really goes to show you that every experience in life is meaningful and productive, even in the worst of cases. You don't have to look for meaning, because just the very act of living through the experience is enough. So another implication is that means there's nothing personal in life. The shit that's happening to you, if your kid gets killed by a serial killer, it's not personal. God doesn't hate you. The devil's not after you. It's not your fault. It's not your karma. It might be important, not in this lifetime to that person, but in the overall scheme of things, it might not be as much of a negative as it appears to be. So when things happen like that in life, don't look at it as a personal attack against you, because that's where stress comes from, and that's where self-loathing comes from, right? There's nothing wrong with you. You're doing what you should be doing. Just relax.
I don't think that or I rarely find that when bad things happen, we tend to look at it in a very, singular kind of way. Okay, because it's always, why do bad things happen to me?
Yeah,
you know what I mean. But the interesting thing is about events like that, whether it's death or sickness or whatever. And I lived through the death of my mother with cancer. And that really sucked for my mom. Absolutely. Right. But we all learned so much from her going through that. Does that make sense?
Mm-hmm.
Yeah. I mean, it was a terrible event for her, but I would say it brought us together closer as a family, like
and in
siblings.
A way, it brings you closer with your own death too. That's
it
inevitable.
Certainly does. Yeah, absolutely.
So it's
so I mean, if I had my choice, I would love to have my mother, instead of her getting sick and dying of cancer, right? But did I learn something from it? Did good come from it? Absolutely. Yeah, absolutely it did.
And
absolutely.
I think me and you both know at least one person who still holds themselves in some way responsible for the death of their father.
Yeah.
And I don't really know what I can say to that person.
Right.
And I feel bad for them, and I hate that they're stuck in that time.
Right.
I know it's just as nerdy as shit, but it reminds me of the beginning of the Deep Space Nine, where inside the wormhole was nonlinear time and beings that lived in there, and they kept asking Cisco, who had lost his wife, why he kept living in that time when he was in linear time and he'd moved past it.
Right.
And everything was moving and going on and grooving. Like, why do you keep putting yourself back in that spot? And he said he couldn't escape it. And they're like, you're not there. It was really poignant for that kind of a show.
Right.
It was
it was making a deep statement.
It really is, man. You're not there. You're moving through. You're never where you're at. You're always moving through it. You're the uncertainty in your own principle, That's all.
Well, no, it's very interesting. This whole theory, I like it. And I would imagine it's just going to continue to evolve, as
and
more and more people
talked about pilot theory too, and the slot
we'll
experiment.
We'll use that for another scientific update from my friend, the historian, Eric Smith.
Scientific update from the historian.
You do come up with some really interesting topics, man. So I'm not faulting you at all, even though you're a historian. And you don't claim to be an expert in any of this stuff anyway. So,
Nope.
Obviously go out and look this stuff up for yourself. There's Wikipedia pages on it, et cetera, et cetera. But I love it. It's an interesting topic. And I would like to do the pilot, is it pilot theory?
Yeah.
At some
it
point
won't be a 2-hour discussion. It's just like a
pretty
thing,
straightforward.
But we worked in something. I tell you, I can talk about things that completely don't exist in this depth too. No, seriously, if you ever want to do a podcast on something that's completely fictional that didn't come from anywhere but inside my head, I can give you 2 hours and you can question the hell out of me if you want.
That could be interesting. That's definitely one in and of itself. Well, buddy, thank you so much for coming on and doing this with me again. I love having you on here. I love your knowledge and the depth of your knowledge about these interesting and obscure subjects. And apparently the audience likes it too. So, so we're going to wrap it up there. That's our show. It's been wonderful. And I guess I'll look forward to talking to you next time.
Bye.